In this exercise, you can learn collision detection on the canvas with JavaScript, along with a few other useful tactics. Collision detection is the act of detecting when specific objects come into contact with one another and then programming some resulting effect of that collision. We're going to be putting the logic into a video game programming scenario to best demonstrate detecting collisions for multiple objects simultaneously. All of the code used in this basic application is code from all of the previous exercises in the bootcamp. So I'm not going to explain the code character by character, since you guys already understand the building blocks of everything that will be applied. First, let's take a look at the finished product of what you'll be learning how to do. When the application starts, we have enemies coming down, and then we have the launcher down here that can move left and right. And then it can also fire missiles. So if I line up and I fire missiles, you can fire as many missiles as you want. And when I hit certain objects, they get destroyed and go away. And then when I finish killing all of the enemies, it says level complete. Okay, you can see we're starting with a blank canvas. The first thing I'll do is go into the body and add some HTML. It's just a little HTML. There's 3 buttons in a div element, and then we have a status element that it's going to output some status to us. Okay, now all we have to do is apply to JavaScript. So the first thing I'm going to do after we establish our CTX object is I'm going to get the canvas width and the canvas height into variables. Then directly under that, I'm going to create a variable. It's an array called enemies. And in this array, there's a bunch of little JSON objects, one for each enemy. Now what we're going to do is just loop over this enemies array to have them come pouring down the screen at the launcher. And what we can do is just put that into a function called render enemies. So we say function render enemies, and then we have a little for loop that runs over the length of the enemies array, and each of the little JSON objects that represents an enemy will get accessed within this for loop, and it can be rendered to the canvas. And you can see what I'm doing here is we're placing the X and Y and width and height at the specified values for each of the objects, but I'm incrementing the Y position by 0.5, which is half a pixel each frame. So they'll go half a pixel down the screen, and that's how I get the effect of them coming down the screen. Now this render enemies function is going to be fired off within an animation loop, and that's how you get the animated effect. Now right under that, or a few lines down, we can put an animation loop in place, and what that'll do is allow us to render enemies in an animated fashion crawling down the screen. You can see our animate interval is set to 30 milliseconds. Press Ctrl S to save it and render in your favorite browser. You'll see that you get the effect that you want. Now all we have to do is add the launcher and then make the launcher shoot some missiles. And we also have to put listeners for these buttons, which we'll do in just a moment. Okay, so right under the function render enemies, we're going to put in an object to represent the launcher. So now I'll pop that into place and I'll explain all the code real quick. Now since we have the new launcher object ready, I'm going to put the render method for the launcher in our animate loop. And you can see one of the methods for the launcher object is hit detect. So let me explain all the code within this function launcher, which creates the launcher object. First, we specify some properties for the launcher. Then we specify the methods. We have a render method. We also have a hit detect method. So we set the Y position at 280, so it's down near the bottom of the canvas. Then we set the X position of the launcher centered in the canvas. We give it a width of 50 and a height of 50. Then we give it a property called dir, which is short for direction. That lets you keep track of which direction that it's being controlled to go by the user. Then we say this.bg equals orange, and then this.missiles equals empty array. And the missiles array is also little JSON objects that we place into the missiles array when the user hits the fire missile button. So it just starts out as an empty array, and when they fire the missile button, we just pack as many little missiles that need to be on the screen into that missiles array. Okay, now this.render method is where a lot of the movement and the shooting logic can occur. So the first thing we do in that render function is we say if this direction is equal to left, that means if the user is pressing the left button, then we're going to make this dot x minus equal 5. That means it'll go in the left direction in the canvas. Else, if this direction equals right, if the user is pressing the move right button, then we're going to say this dot x plus equals 5 to move in the right direction. Then we give our launcher a background or fill style, which in this case was orange, and then we place it on the canvas. And remember that the launcher.render method is the one that's fired off within your animate loop. So it's going to be fired off a lot, constantly. And it's always going to be listening for hit detection and movement, or ready to react to hit detections and movements, and firing of missiles and all those things. So to fire off the missiles, what we're going to do is for loop over the missiles array length. Now we get all the missiles into the missiles array when the user presses the button, which is the fire button. Down in the HTML we have the fire button down here. When they hit that fire button, all we're going to do is push a new little object into the missiles array that'll represent a new missile. So here we're looping over the missiles array simply to render them to the screen. And since the missiles are being shot from the bottom of the screen up, we can just take each missile and minus equals 5 on its Y position to give it upward movement. Then once it's rendered and it has upward movement, we also want to hit detect for every missile against every enemy. And I'll explain this method hit detect in just a moment. The next little bit of code is to see if a missile goes past the canvas boundaries, then you want to remove it. So you say if the missile.y position is less than or equal to 0, then we're going to splice it out of the missiles array so it no longer exists. Because you don't want a bunch of missiles that are outside of the canvas, taking up memory for your program or hogging up graphic resources or whatever. Or maybe it wouldn't if it was outside of the canvas, but still you want to make sure that you just remove those things. If they don't exist on the canvas anymore, there's no use having them still be in the program, and you don't have to be moving them still outside of non-visible space. So that's the only reason we put this in place, is just to remove a missile if it goes past the boundaries of the canvas. And this little bit of code is for ending the level or the board. You say if the enemies.length is 0, if there's no more enemies, then you clear the animate interval and you put some text on the screen that says that level is over. And then under here you put whatever code you want to load the next level or whatever you want to do. Now for the hit detect method, we're passing two parameters. The first parameter is the missile in question and the missile's index within the missiles array, where it lives, what position it lives within the missiles array. That way we can splice it out when we need to. If it happens to hit an enemy, you want to get rid of the missile. You don't want the missile to keep going through the enemy. Unless you want that, then you don't have to remove the missile. But I just chose to remove the missile when it hits an enemy. That way the enemy explodes and the missile explodes. They no longer exist. So for hit detect, the logic is we for loop over the enemy's array length. So for each enemy on the screen, or for each enemy that's still alive within the enemy's array. So what I did was I just named each E within the loop to make things easier within our hit detection evaluation. So each enemy within the loop gets represented by this E. Now here's our hit detect logic, which is similar to the mouse hit detect logic, the finger touch hit detect logic that we did yesterday in exercise 18. Now all you're doing here is setting up a rectangle bounds to see if the missile is in the same space as any of the enemies. So we say if the missile.x position plus the missiles.width is greater than or equal to the enemies.x position, and the missiles.x position is less than or equal to the enemies.x position plus the enemies.width, and that takes care of your horizontal space. Then for the vertical space, we want to say and m.y position is greater than or equal to the enemies.y position, and the missiles.y position is less than or equal to the enemies.y position plus the enemies.height. So you run all of that math, and that'll do is give you a boundary that tells you if any of the pixels of the missile are in or on or have come in contact with any of the pixels of the enemy. You just want to make some kind of equation that lets you see if any pixels of the missile have come in contact with any of the pixels of the enemies. And the way our code is set up, each missile that's fired, even if there's 20 missiles on the screen, they're each hit detecting all of the enemies. So if any of those hit any enemies, we'll get the results that we want. And that is all of the code. Then all we do underneath the launcher object is we say var launcher equals new launcher object. That way we have a reference, a new instance of that launcher object, and we say launcher.render down inside of our animate function. Now all we have to do is put in the button listeners, the event listeners for those little buttons in our HTML, and we'll have a working application. Okay, so I'm going to go under the animate interval where I put the animate interval, which is basically the last line within our application, and we're going to pop in the listeners for all of the buttons. So we say var left button is equal to the left button that's down on the page here. We're going to do the same for the right and the fire button. So we have object references for all three of those items. When we say left button, we add an event listener for mouse down, and when the user presses the mouse down, we just take the launcher and make its direction property equal to left. That way it starts moving left. Then we want to make sure that when the user mouses up on the left button, when they let go of it, that we make the direction equal to nothing. That way there's no more movement. And that's also a smarter way to program your keyboard movement. If you're going to supply movement in video games for keyboard controls, you can just set the direction in the listeners for those keyboard events, those keys when they're pressed. Set the direction, and then when the user key ups, when they let go of the key, you can just set the direction to nothing, and then your movement will stop. Now for the right button, we do a similar thing. We make the direction right this time though, instead of left, and then when the user mouses up, we make the direction nothing again. That way movement stops. Now here's the little important part. The fire button. When the user hits that fire button, we push a new little JSON object into the missiles array. That way there can be as many little missiles on the screen as there needs to be, and we can handle their position and all of the little properties that we need to independently for each little missile. And it's easy to handle them if we put them into little JSON objects that are packed into an array. And we can easily for loop over that array. So every time this fire button is pressed, you're going to pack a new missile into the missiles array. And each missile gets an X, a Y, a width, and a height, and a background. You can give it any properties you want. You can give them all custom properties that you need to have for any of your objects. And we make the missile shoot out from the front. Let's see if we have a working application. Okay, we're firing missiles. We destroyed enemy 2. Let's move left here. Fire a missile. Fire a bunch of missiles. So no matter how many missiles we fire, they go away when they leave the screen up top. Alright, we have a working application. Now if I get, the way I'm getting the missile to come out the direct center of my little launcher down there is we're setting the X property equal to the launcher.x plus the launcher.width times 0.5, which is divided by 2. So you take the launcher width divided by 2 and you add it to the launcher's.x position. That'll give you a dead center on the X plane. Dead center to relative to where the launcher or the ship is. Then the Y can just be simply equal to the launcher's.y position. That'll make it come out the top. Then you set the width for your little missile and the height for all your little missiles. And basically that is all of the code. Alright, so now you have a really good understanding of how to detect for collisions for any of those arrays of objects. And there's a lot more additions you can add to this code to make it a more complete game if you just sit there and put the time into it and work on it. So that completes collision detection, and we've done it in such a way that allows you to detect collisions for a whole lot of different things that are on the canvas at the same time, many objects simultaneously.